Okay, so yeah. Then, if you have ever tried to make a cup of tea using an electric kettle or even a gas cooker kettle, there's something I have always wondered about particles. Just pause the video for a moment and think, what is it that is so beautiful about these particles that you observe when you try to make a cup of tea? If inside the kettle there is, let's say, 500 milliliter of water, there is, when you give the heat energy, when you give the heat, all the water molecules absorb it and share it. Not just one portion which is closer to it absorb all the heat and convert them to gas, steam, and let the remaining molecules still be liquid. But they absorb and they wait till other molecules also get enough heat, and until all the molecules get to 100 degrees Celsius, until all the particles in that liquid get to 100 degrees Celsius, rest of the particles wait. They wait patiently. They don't say, I have no time, I have to rush and I have to go. No. All the particles will wait till the heat is shared and all the particles reaches 100 degrees Celsius. Then together as a group only they would start getting converted into steam. That's why you can have a couple of minutes to wash your cup or something while the water is being heated up, because the steam is not going to appear immediately. You have got some time. It is now there is a table manners, right? When you are in a function and you are eating, you don't just get up and go and wash your hands or go away once you have done eating. It's a gathering, so you just wait patiently till each and every one of the visitors, the guests, have finished eating. Or in the current scenario, it's there's no panic buying in change of state. There's no panic buying in particles. The particles don't hoard or stock more than what they need. They buy and they share to every other particle and they wait till all the particles reach that boiling point or whatever the melting point. Okay, so one peculiar thing you observed earlier in the lesson is during the change of state, the heat energy that you supply goes hidden because it is not being used to change the kinetic energy but is being used to break the bonds. That's one thing. The second thing is this: there is a certain unity among particles, that none of the until all the particles reach the melting or boiling point, there is no change of state. Okay. The other thing is we learned that solid to liquid is melting, and we learn that liquid to gas is boiling. The reverse can also happen. The gas can lose energy and can condense back to liquid. We call it condensation. And the liquid can lose energy and can condense back to solid. We call it not condense back, like it can become solid. We call it solidification. Okay, so melting, boiling, condensation, solidification.